Are you understanding what I'm saying? Am I being clear?
Yeah,
So the
you're
more
just
of these you have, the more
you'd
of
be
these you
randomly
have. Go,
go
Charles.
ahead. Oh, you'd be randomly picking these up, going, nope, that's not it. Nope,
Yeah,
that's not
you
it.
get into this loop where you're like, okay, I already got that one, I already got that one, I already got that one. And this gets just worse and worse the more values you've got to choose from. So it works, and for 4 cards, you wouldn't notice. But here, let's do this.
Yeah, it doesn't scale.
I want to demonstrate this. I know we're running out of time, but the other parts are pretty easy, so hold on. Equals 0. And then we'll just say count equals count plus 1. And do it in the loop here too. And then we'll print out count. Okay, so ideally, we'd get a count of 4, right? But in reality, even for 4 cards, we can find it here. Here's our doohickey. Where is it? I've lost it. There it is. It took us 7 tries to get 4 cards. Let me just push this off to the side. Uh-oh, I think I've crashed it. Yep. And then as soon as you introduce a coding error in your code, it goes on forever. It goes on because I didn't clear selected. That's a great example. I'm so glad you brought that up, because there you go. That's exactly what happens. Naive approach crashes your program. But it only does it arbitrarily at some future date when you thought it was working. Not in the middle of the show. Or perhaps in the middle of the show. And, of course, it happens in such a way where you don't have your code in an easy place to pick it up. Ba-dum. All right, there it is. So, back in business. 9 count. 14 tries. 13 tries. Clearly inefficient, right?
Yeah, definitely.
Okay, so what we want is we want to always get exactly the right amount, and we want to get it the first time. I want to randomly select it one time and get a card that I know for sure is not a repeat. It's one of the cards I put in my shuffle bag. And so the way that works, very quickly, is I have included a new module here, which you can just use right out of the box without even understanding how it works. But how it works is in bag 1, which is hooked up to this green button here, you say local shuffle bag require shuffle bag, which will load the module and return a reference to it. And then we say shuffle bag new, and there's 2 ways of using it. You can just pass in your list of elements, and what this does is it creates a shuffle bag and it puts 4 cards in there. Now this is one way. Bag 2 below, the example will show you a different way. And then you say, the first time you fill it up, you say shuffle. So initially when you put them in, they're in the order Jack, King, Queen, and Ace. And if I were to pull them out, I would get Jack, King, Queen, and Ace in exactly that order, which is not what I want. So we tell the bag to shuffle it, to shuffle itself, and then we use it pretty similarly to the way we used our previous piece of code. We just say in a loop, cards, get, and it will return Jack, King, Queen, or Ace. And I know that there's a question lingering there as soon as I say well, you're thinking, what happens when I get the 5th card? When I put 4 cards in, what if I call get 5 times? We'll get there. But the point is that the way this works internally is it keeps a list in a smart way, and it knows that it's already given you the Jack and the Ace and the Queen, and the only card left here is the King, or Jack, Queen, Ace. Oh, I'm sure I get the exact same. King, Ace, Jack, Queen. Okay, so to answer the question, what happens if you pull 5 cards, is shown in bag 2 example. Here we say shuffle bag require shuffle bag, and we create a blank shuffle bag. So we just say shuffle bag new. It doesn't have anything in it. And then I insert the 4 cards. So this is the alternate way of adding content. And you can pass in anything. You can pass in a string. You can pass in a table. You can pass in a reference to a display object. It's a universal container. It doesn't care what you put in it. You can put in some strings and some other things, you know, however you want to use this. Content is content. It's just going to give you things out of the bag, has no idea what they are, it doesn't care. We've inserted our cards, so we do a shuffle. And then this one, when I push the button, the blue button, it'll pick out 4 cards and a 5th card. And what you're going to see is exactly what should happen. The shuffle bag will always, in the first 4, return randomly sorted Jack, King, Ace, and Queen in some order, and you won't get a repeat. But as soon as you go beyond the edge of the bag, the shuffle bag class or module has the ability to say, oh, I ran out of cards. They're asking me for more cards. I'm not going to return nil. So then it takes the bag and it refills it with all the cards that were previously in it, shuffles it up automatically, and then gives you the next randomly sorted card. So you're going to see, if we call this 8 times, we would get some Jack, King, Queen, Ace, and then we'd get 4 more random cards, but each one would only repeat 1 time. So we'd have 2 aces, 2 kings, 2 jacks, and 2 queens. And then when we got to the 9th selection, we might have 1 more of each, and so on and so forth. So not only does this return exactly the cards that are in the bag, and you don't get repeats, but it's also smart enough to maintain the ratio. So if you have a bag with 4 cards and you call it 400 times, you're going to get 100 of each card. Does that make sense? Mm-hmm. Charles's eyeballs are moving. I'm focused on Charles's camera here, so I get to see what Charles is thinking.
Yeah. I was actually thinking that this smacks a lot of data structures, which is a class that computer science students take. And,
it is actually, the shuffle bag is nothing more than the implementation of a basic data structure.
Yeah.
It's Charles. You're just saying all the right things today. Now I know that we're out of time, but let me just iterate over how this works for people. If you go open the shuffle bag module, you're going to see that it's a module like always. So I say local shuffle bag and a table, and then I have a function here whose job it is to take a table and randomize it, and it's used internally. But then we start to attach functions, or I create functions that are going to be attached to individual shuffle bags. I have an insert function that takes argument self and object. So you can say insert and some object, a string or something like that, which is here. And then we have the shuffle function, and that basically says shuffle the contents of the bag. And we have a get function, which returns the next value out of the bag until the bag is empty, and then assuming that the bag is empty, if the bag is found to be empty, it will refill the bag and automatically shuffle it. And then we have finally shuffle bag new, which takes an arbitrary number of arguments, or none if you wish, and the way it works is it creates a table called bag. It creates 2 subtables, one called used, which is the cards that have already, or the objects that have already been selected from the bag, and another one called unused, which is the current contents of the bag. And then we attach our functions, which were created above. So we attach insert, shuffle, and get. And then if anything was passed in, we automatically call the insert function on each of those arguments, and it returns the bag. And that is it. This is very